Assalamualaikum and good morning everyone. Let's continue our basic pharmacology courses. On your previous lecture, you have learned about the pharmacokinetic, which consists of absorption, distribution, metabolism and excretion. Today, we will cover the pharmacodynamic part of the pharmacology. This is the learning outcomes. At the end of the lectures, you should be able to understand the basic principle and concept of pharmacodynamics. You need to be able to differentiate between the agonist and antagonist. Also, you need to identify the various target protein involved and its interaction with drug. And you need to interpret the graded dose response curve and compare the efficacy and potency of the drugs on the basis of the dose response curve. The first two parts of the introduction of pharmacodynamics and drug-receptor interactions will cover on this lecture, and the last part, the third part, which is drug actions, will cover on next week. Let's begin with the introduction of pharmacodynamics and how it differs with pharmacokinetics. Pharmacokinetics refer to the movement of drugs through the body by characterizing absorption, distribution, bioavailability, metabolism, and excretion as a function of time. Whereas pharmacodynamics refer to the body's biological response to drugs. On a simple word, we can say pharmacokinetic, how the drugs react on the body system, whereas pharmacodynamic, how the body reacts to the drugs. This is the general idea what we will cover on the pharmacodynamic part of the lectures. Pharmacodynamics is the study of the biochemical and physiological effect of drugs and their mechanism of actions. Mechanism of action is a term that explains how a drug works and produces its desirable and sometimes undesirable effects. The effect of the drug can be seen once it binds to the receptors of any target proteins. This binding will produce pharmacological effects that can be measured using the dose-response relationships. The drug can be antagonist, can be agonist, which will cause changes in the biological response that can be measured through the therapeutic index. The measurement of therapeutic index are beneficial to avoid any toxicities, especially for drugs that has narrow therapeutic index. On this part, we will cover on the drugs, the receptors, and their interactions to produce the biological effects on our body. Ligands is a substance that form a complex with receptors to serve a biological response on our body. Ligands can be drugs, hormones such as insulin, cortisol, and estrogen, as well as neurotransmitter which is acetylcholine, epinephrine, and norepinephrine. These drugs or ligands can be bound to the receptors or any target protein. The binding of these ligands can be either receptors, ion channels, transporter, and enzyme. This binding will exert a biological response in our body. Here are the examples of the receptors, ion channels, transporter, and enzyme that coexist in our body and being actively studied by the researchers for the treatment of any diseases. Basically, there are four types of major receptors in our body. The drug or ligand has high affinity to bind only to the certain receptor due to the selectivity of the receptors. The first receptor that can be found in our body is enzyme-linked receptors, such as insulin receptors. The second is ligand-gated ion channel receptors, such as nicotinic, cholinergic, GABA-mediated receptors that allow influx or exflux of the ion in our body, such as natrium, potassium, chloride ions. Another third receptors that can be found in our body is G protein coupled receptors. And the last one is intracellular receptors, which receptors can be found in the cytosol, such as steroid receptors. A protein-ligand complex is a set of complex interactions once the drug binds to the target protein. This binding will activate the receptors to induce the signal transduction, which also known as the second messenger, which will exert the biological response in our body. The binding of the drugs to the receptors follow the lock and key model. So this concept is closely related to the formation of complex between enzyme and substrate or antigen and antibody. Receptor has high and selective affinity for the drug's molecule or ligand. The binding of the agonist ligand can change the receptors from inactivate state to an activate state. In contrast, antagonist ligand do not activate the receptors once it bound to the receptors. As I mentioned earlier, the binding of the ligand to specific receptors can produce a biological response. This response, as you can see in this chart here, is a graded effect, meaning that the response is continuous and gradual. With increasing drug concentration in log mode at S-axis, there is an increase in the biological effect on your y-axis until the maximum effect is achieved. And you can see here the curve becomes sigmoidal in shape. The response produced by each dose of drug is described in terms of percentage of the maximal response. Emax is a maximal response that can be produced when all functional receptors are occupied. In our practice here, to study the effectiveness and potency of the drug, we will look up the EC50, which is the concentration of the drug that can produce 50% of the maximal response. From the log-graded dose response curve, you can measure the potency and efficacy of the drugs. Potency is the measurement of the dose of drug that required to produce a maximal response. The potency of drug can be compared using the EC50. As you can see in the chart here, the drug A has a lower concentration to produce the EC50 compared to the drug B. It means that the drug A are highly potent compared to the drug B. For the term efficacy of the drugs, which means the magnitude of maximal response of a drug can be produced, also known as intrinsic activity. And as you can see in the chart here, the drug A has higher efficacy compared to the drug B because of drug A produces 100% of the response. Meanwhile, for the drug B, nearly 50 to 75% of the drug response. Question is, the graded dose response curve shows the analgesic drug that acting at the same receptors. The question, which drug are most potent and efficacious? Let's have a break first. See you on the second part of the lectures.